The more space-themed videos I create, the more I am amazed by the versatility and mystery of the laws of the universe. Answer a simple question: is it possible to look beyond the horizon? Of course, because it is worth to go a little forward, and we will see what is hidden behind it. And on the planet of the Little Prince, it is even easier to do it. If you want, you can watch sunsets on asteroid B6112 several dozens of times a day. To do this, you just need to move the table closer to the horizon. But the phenomenon we will talk about now does not belong to the category of easily surmountable obstacles. More precisely, it is impossible to overcome it. We will talk about the event horizon of a black hole.
First in outer space.
Let's start with the terminology. What is an event horizon? It is a three-dimensional hypersurface framing the space monster. The imaginary line may well be called a point of no return or a one-way ticket, because everything beyond this boundary is lost to the observer forever. Even super-fast photons of light. An object or a living being caught in this hellish vortex will sooner or later reach the point of singularity in the very center of the black hole. But to the final point, the object will most likely arrive not in one piece. Beforehand, it will be torn apart by an incredible gravitational force that is unmatched anywhere in the universe. Why do we think there's a singularity out there? Because we don't know what's inside the black hole. Information about it is classified by nature itself and protected by barriers from the inexorable laws of physics. But mankind continues to speculate to confirm which would help to travel beyond the event horizon and back. Is it possible? First, let's find out, where do black holes come from? Astrophysicists know this for a fact. Massive formations eventually turn into heavy stars, which live a life too fast by the standards of space. Who can be called real candidates for the title of future black holes? These are stars that burn their fuel over tens of millions or billions of years and combine several hundred solar masses. When hydrogen reserves run out, megatons of stellar matter are instantly collapsed by hellish gravity. Burning like torches, the stars produce unimaginable flares and shrink so much that the particles that make up the former luminaries literally grow into each other. Some of them become neutron stars, but particularly dense and heavy objects become invisible monsters of the universe. They are so massive that they literally fall through the spatial fabric, creating depressions or funnels. Theoretically, any space body can become a black hole, even the Sun or the Earth. For example, for our planet to turn into an invisible magnet, its radius at constant weight should be 1 centimeter, and for the Sun, this figure is equal to 3 kilometers. The critical compression of a body is called the Schwarzschild radius. And now, returning to the question asked at the beginning of the video, let's ask again whether it is possible to leave the inhospitable embrace of black holes. Physics in this question is adamant. To break away from any space body, it is necessary to develop the second cosmic speed. For the Earth, it is 11 kilometers per second. For the Sun, 617.7 kilometers per second. For a black hole, the second cosmic speed exceeds the light speed. And to achieve this, as we know, it is impossible. So we're done talking because we can't leave the event horizon. Is that the end of the conversation? We are persistent people, so let's try to dig deeper. What if we try to tie some object with an incredibly strong cable to the ship and lower the object into the pitch blackness of the black hole, or use an elevator for this purpose? Is it possible to pull an object back up like a ship's lot from the ocean depths? It would seem, what's the big deal? It will plunge, explore the vastness of the universal trap, and finally satisfy the keen curiosity of mankind. We have to disappoint you. not in this universe. The further and most probable scenario in such a situation is the gradual pulling into the darkness of the hole, not only of the object tied to the cable, but also of the ship itself. They will inevitably rush to the Holy of Holies, the region of singularity, the point of beginning and end of everything. In this case, the size of the vortex does not play a role. The principle of no return is the same for all types of holes. And what will happen if a person who's on the very edge of the event horizon tries to plunge into the abyss of the terrible vortex only an arm or a leg? It can be instantly pulled back. Absolutely not. As already mentioned, everything that falls into the clutches of the hole never returns. One can only hope for the mercy of a nearby astronaut who will cut off the limb of the daredevil before he is sucked in completely. And what about the optimistic statement of Stephen Hawking, who urged not to give up, saying that even from this cosmic coffin there is a way out? It exists, but not the way we'd like it to. A fact that will give some comfort to the traveler plunged into a black hole is that it is not eternal thanks to quantum physics. The lifespan of a deadly formation is enormous, but everything comes to an end sometime, although it should be taken into account that the event horizon will exist until the last milliseconds of the black hole's life, until the moment when its mass becomes zero, and that's where liberation comes in. Stephen Hawking claimed that in the hour of the final collapse of the black hole, the vortex gets rid of unnecessary information. It spits out jewels in the form of radiation, and the power of the death cry of the space monster can reach up to 5 million megatons in TNT equivalent. The information that the hole will emit during its agony includes that which contains information about the bodies that have ever fallen into the monster's belly. It can be compared to the urns in a columbarium. The ashes store scraps of information about the burnt man, but they are of no use anymore. Although, from the point of view of physics, this extravagant explanation resolves the paradox about the transformation of energy and its immortality. It is a pity that no one will be able to admire such an impressive event, because by that time, there will no longer be a single star or other source of light in the universe. If the moment of death of the last black hole could be seen by any of us, the picture would be stunning amidst the pitch blackness and emptiness lasting 10/100ths of a year. Suddenly, there would be a blinding flash, the last ray of light in space, and then the silent explosion of the black trap would finally release those who once recklessly fell into its net. Thus, there is still a way out of the black hole, but the information about it in a practical sense for us is unproductive, although colorfully interesting to create imaginary pictures. The conclusion is obvious. Until mankind is armed with sufficient knowledge and improved technology, it is better not to approach black holes and admire these frightening objects from afar through the eyepieces of telescopes. If you do not agree with the conclusions drawn by astrophysicists, then bravely parry. You may be the one to find the solution that the rest of us have overlooked. The payment for this issue is small, a like and a subscription. For those who haven't yet, keep in mind, the Hubble channel is a living portal with regularly updated content and feedback. Stagnation is not about us.